Alright, we're going to be starting something new. It's called trigonometry. Some of you have done it before, if you had foundations of math too, and others probably have not. We're going to start with the Pythagorean theorem, and I'm sure that you guys have done this before. What you should know about the Pythagorean theorem is that Pythagorean theorem only works if you have a right triangle. So, first of all, make sure you have a right triangle. If you don't have a right triangle, Pythagorean theorem is not going to work. And then the rule says that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Alright, the hypotenuse is the side across from the 90 degrees. You'll see your little box, or it'll say 90. That's the hypotenuse. So C is the hypotenuse. Alright, and the legs are the other two sides. So the rule is that A squared plus B squared equals C squared. It doesn't matter where you put A and B as long as you have C at the right place. So, looking at number 1, I know that the X is the hypotenuse because it's across from the 90. So I'm going to take 9 squared plus 12 squared and equal it to X squared. Alright, to solve for the answer, I'm going to add 9 squared plus 12 squared, because they're on the same side and they've got a plus. And then to find X, you take the square root on both sides, and you get 15. Okay, number 2. So the side across from the 90 is the C, so that's 24, that's the C. These two are the other two sides, so we would have X squared plus 6 squared equals 24 squared. Alright, so we're trying to solve for X. And I need to move this over here. So that means I'm going to subtract 6 squared on both sides. Make sure you put that in correctly. 24 squared minus 6 squared. And you get X squared equals 540. So then to solve, you're going to take the square root on both sides. So we do square root of 540. And we're just going to leave our answers in decimals for now. So we get 23 point, and let's do it to 2 places. The 3 would round up, so 23.24. Okay, number 3. Across from the 90 is the hypotenuse, so that's the C. This must be A and B. So X squared plus 8 squared equals 21 squared. Again, I want to subtract this 8 squared to get the X by itself. So in my calculator, 21 squared minus 8 squared. Alright, and then take the square root on both sides. So you get 19.4. Alright, the last 2 examples on this page are just showing you how you could use the Pythagorean theorem to solve things. It's just setting it up and making sure that you recognize it's really not too difficult, but I just want to go over it with you. On this one, basically, you just have Pythagorean theorem here and Pythagorean theorem here. So it's just 2 different Pythagorean theorems to solve for X. So let's set X and Y. So let's just say we're solving for X, so we're just looking at that right triangle. Notice that the 90 is across from the X, so X must be C, so we're going to use 9 squared plus 5 squared equals X squared. Add 9 squared plus 5 squared together. We get 106. Take the square root of 106. Okay, and then for Y, again, Y is across from 90, so those are my legs. So 3 squared plus 5 squared equals Y squared. So 3 squared plus 5 squared, take the square root of that, and so you get 34, and then when you take the square root of 34, you get 5.83. Alright, number 5 and number 6. So just so you recognize what's going on this problem, notice that it tells me that this whole side is 10. So that means that each part of the sides here are 5. And once I recognize that, I can do Pythagorean theorem with this part of the triangle. Across from the 90 is 12, so that's the C. I'm going to do the problem above it. So I have x squared plus 5 squared equals 12 squared. And we'll subtract 5 squared on both sides. 12 squared minus 5 squared, I get 119. And then I'm going to take the square root of 119. And I get x is 10.91. Okay, number 6. So here I want to find the whole side, but what I'm going to do first is I'm going to find part of the side, and then I'm going to multiply by 2. So let's say I'm going to find this part here. 15's across from there, so I've got y squared plus 9 squared equals 15 squared. Subtract the 9 squared on both sides. Get 144. Take the square root, so that means y is 12. Well, if y is 12, and this is also 12, that means that x is 24, and you just add it together. Now, if you do not have a right triangle, and you're trying to determine, well, is this a right triangle or not? See, if you look at these examples right here, a lot of them look like they could be. What you do is you do Pythagorean theorem, and then you check to see if it works, or if it's greater, or if it's less. Okay, so here's what we want to do. The biggest side is 16, so I know that that is the c squared. Okay, so the other two sides are a and b, so we would have 9 squared plus 12 squared, and then 16 squared. Okay, we don't know if it's equal yet, so I'm not going to write the equals. So I'm going to put in my calculator 9 squared plus 12 squared, and I get 225. 16 squared is 256. So what we do is we always look at the bigger side. If the bigger side is bigger, that means that the triangle is obtuse. So the bigger side is bigger than the other two sides add together, so this one is obtuse. Okay, let's look at this one. So here's the bigger side. So I'm going to do 9 squared plus 9 squared, and then 15 squared. So 9 squared plus 9 squared is 162. 15 squared is 225. This is bigger, so again, obtuse. Okay, so we have a bigger side here, so we're going to take 6 squared plus 8 squared, and then 10 squared. I know that 10 squared is 100. 6 squared plus 8 squared is also 100. It's equal. Because it's equal, this is a right triangle. Okay, so number 4. I'm going to change that to a 14. I think it said something else earlier, but I'm going to change that to 14. That's the bigger side. So we're going to have 12 squared plus 9 squared, and then 14 squared. So 12 squared plus 9 squared is 225. And then 14 squared is 196. Look at the bigger side. It is smaller than the other two together, so that means that our triangle is acute. Okay. The next two I just wanted to show you real quick just because they have some square roots in them and it's kind of weird. I think 15 is the biggest side, but if you aren't sure, put 2 square root 14 in your calculator. It's 7.4, so that means that the bigger side is 15. So we're going to take 12 squared plus this squared, and then it's not equal. We don't know if it's equal. 15 squared. Alright, 15 squared is 225. When I do this, just make sure that you put parentheses around it. You can always use Desmos when you're doing this, or you can use your calculator on your phone if you can figure out how to do the square root. But Desmos will work just fine. Alright, and here's how I put it in my calculator in case that's helpful for you. Okay, when you press enter, you get 200. This is bigger, so that means obtuse. Okay, and let's do this one. Square root of 257 is 16 something. Square root of 61 is 7. This is the bigger side. So we're going to say 5 squared plus square root 61 squared. And then we're going to try to figure out square root of 257 squared. Alright, so in your calculator, have that, 5 squared plus square root 61 squared. And then square root 257 squared. So this is 86, and this is 257. Again, this is bigger, so that means that this is obtuse. Okay. Now, very quickly, a couple more things in case they do not give it to you in triangle form. They might just give you some numbers. Do the same thing. So 5 squared plus 12 squared, and then we have 13 squared. This is 169. This is also 169. That's equal, so this is right. Okay. 4 squared plus 12 squared. Just make sure that you always put the bigger one over here. That's 169 again. This is 160. This is bigger, so it's obtuse. So this is bigger, it's obtuse. This is smaller, it's acute. There's plenty more problems that I could try with you, but I think that's enough for now. I think you've got the idea.